So now we're starting two-dimensional motion. Let's go back to what a vector is. Remember, a vector is a quantity that has both magnitude, which is size, and direction. So as a reason to do this, we have had problems where we wanted to find the displacement of a multi-part path, but we restricted ourselves in the last unit to only doing forward and backwards, north and south. Now we can do north and south and east and west. So if I make up some random numbers, we are going to have somebody walk 15 meters east, and then we're going to have them walk 20 meters north. So where's the red pen? The shortcut would have been along what I've done here in red, and we call this the resultant. So we need to know both the magnitude and direction of this resultant. To get the magnitude, we're going to use the Pythagorean theorem. Pythagorean theorem. So if I grab my calculator, I need to do 15 squared plus 20 squared. Take the square root of that whole thing. 15 squared plus 20 squared. Take the square root. Well, that wasn't on purpose. It turns out that that's 25 exactly. Oh well, life goes on. Now, that's the easy part. Now we need to talk about trig. I also need to know what direction. If you only know to go 25 meters, I'm not going to end up here unless I get this exact angle right. And so we are going to call this the Greek letter theta, or this is the Greek letter theta. We are going to use it for angles in this class. And to calculate this angle, we know the two legs of the triangle. So for those of you who already know, or will soon learn, SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. For this angle, 20 is opposite, 15 is adjacent. This is the hypotenuse. We're going to pretend we don't know this because what if we messed up? So if I know opposite and adjacent, that's tangent. So the tangent of this unknown angle is the opposite side 20 divided by the adjacent side 15. I don't want to know the tangent of the angle. I want to know the angle. So you know, to get rid of addition, you subtract. To get rid of multiplication, you divide. To get rid of a trig function, you do the inverse trig function. So theta is equal to the inverse tangent of 20 over 15. It is on all calculators. On my graphing calculator here, you can see above the tangent button is the tangent to the -1. It's in yellow, so I have to hit the second key. So since that's actually showing up on the video, I need to do the inverse tangent of 20 divided by 15. And I get 53.1 degrees. So this angle is 53.1 degrees. You're only going to get that if you're in degree mode. Please be in degree mode for the vast majority of this class. You'll use radians and pre-cal. We are once going to use radians in here, but most of the time we're going to use degrees. So to finish this problem, if this person walked 15 meters east and 20 meters north, the shortcut, the resultant, would have been to walk 25 meters at 53.1 degrees north of east. So when I've had you do basic angles before, we use things like northeast. This is how you actually calculate it. But as you're going to learn in pre-cal, we measure angles all the way around the circle, called the unit circle. And I'm going to draw a coordinate plane here, because these are the 4 quadrants. So this is quadrant 1, this is 2, this is 3, and this is 4. So in quadrants 1 and 4, x is positive. In quadrants 2 and 3, x is negative. In quadrants 1 and 2, we're next to the positive y-axis. So positive y, and these two are on the negative y-axis. So y negative and y negative. So you can see there are four distinct possibilities, both positive, both negative, negative, positive, positive, negative. This is important because if you haven't, this problem was in the first quadrant. It was positive x, positive y. So the calculator gave us the correct answer. So use the calculator answer. In quadrant 4, you will also get the correct answer. Use the calculator answer. It's going to be negative, and that's okay. The calculator defines, and pre-cal, and virtually all of math, this is 0 degrees. And the numbers increase around this way. So if this is 0, this is 90 degrees, this is 180 degrees, and this is 270 degrees. If you go the other way, they're negative. So this would be negative 90. For our Schoology entrance things, I'm not going to let you use negative numbers past there. It gets weird to do like negative 120 or something. So use positive degrees for each of these, and this one can be negative. So here's the problem. Remember domain and range? The range of this function, the outputs, are only between 90 and negative 90. It will not give you an answer in the second or third quadrant, even if you put in something for the second and third quadrant. That's because when you do the division, if this was in the third quadrant, these would both be negative. Well, negative divided by negative is a positive answer. You'd get the same positive number. Same thing over here. Positive divided by negative and negative divided by positive, same thing. So you always need to sketch what your components are. If you are in this section, highlighter, sorry, you are going to add 180. You know that 180 degrees is the measure of a straight angle. So if you had, let's say, negative negative here, so it should be 53.1 from here, but it's over here, add 180. That takes you across to the opposite quadrant. So to summarize, if you know your answer should be in quadrant 1 or 4, use what you get off the calculator with the inverse tangent. If your answer is supposed to be in quadrant 2 or 3, you have to add 180 to the calculator answer. So that's the first half of vector basics, resultant. The other part is components. So we have a student that walked diagonally across the courtyard. Let's make this diagonal walk 50 meters, but the angle they walked across the courtyard was 55 degrees. Just making up a number here. So instead, this student could have walked east, then north. So this is the x component, named after the x-axis, and this is the y component, just like the y-axis. We know the hypotenuse. So if you again go back to so, ka, to, wa. I know the angle, I know the hypotenuse. If I'm looking for the x component, that's adjacent to 55. Adjacent and hypotenuse is cosine. So the x component is the resultant times the cosine of the angle. The y component is the resultant times the sine of the angle. And we know the angle, so we use cosine and sine as is. There do exist inverse functions for sine and cosine. We're not going to use them for this thing because we know if you know the angle, use a regular trig function. If you're looking for an angle, you use the inverse trig function. So for this particular walk, we need to do 50 times the cosine of 55 and 50 times the sine of 55. 50 cosine 55 is 28.7 meters. 50 times the sine of 55 is 41.0 meters. So the student who walked 50 meters diagonally across the courtyard could have walked 28.7 meters east and then 41.0 meters north. So this is the reverse of what we did up here at the top. We took two legs and put them together. We took the hypotenuse and broke it apart. So the two components and the resultant, they're opposite factors of each other. So the last thing I want to mention are unit vectors. This is a shortcut notation. Unit vectors, we use the symbol I for X and J, oops, I like to put these little hats on them, J for the Y direction. Notice they're in alphabetical order. I comes before J, X comes before Y. So I could write this vector we just did, 50 meters at 55 degrees, as 28.7 meters in the I direction plus 41.0 meters in the J direction. So instead of saying X component, Y component, I is for X, J is for Y. So this is an equivalent representation. Hypotenuse, two components, using unit vectors. They're called unit vectors because they purely indicate direction. They do not have any size. They do not have any, they do not have a unit. So you've got to include the unit over here. And that's it for Vector Basics.